Yes.
How many questions?
It changes. So, listen, I believe it's 60 questions, but 10 of them don't count. So they're called field. They're called field questions, where they're trying to experiment if those questions will work for a future as well. So if you get them wrong, they don't count against you. I think there's just the 50 that do.
It counts for 40. Yeah, it does count 40. It's 2 points. Oh. That's why I know. Like when you get the 50 questions, it counts for 40.
I didn't know that. That's interesting.
What if you fail all and get the 10 questions right?
Exactly that. Anyways, all right. Moving on to our last lesson for today. So day one. Day one, we learned how to graph exponentials and then work with those application word problems. Day two, we introduced logarithms and saw the relationship between exponentials and logs. And now today we're going to be learning how to graph logs. So we're bookending the unit with the graphing part. So now that we've talked about logs a little bit, now we're going to graph them. The way that we graph and analyze is very different from how we work with the exponentials. So I mentioned this before, but just to remind you guys what I mentioned very briefly before, a log and an exponential, they're inverses of one another. Right? So they're inverses. That idea is going to come back more significantly at the end of this lesson after we finish graphing. So this right here, this upper graph, is an exponential, right? It's an exponential growth because it starts flat and then rises. So this is 10 raised to the x power. That's what the exponential looks like. The log is the inverse of that. And actually, I typed this out wrong. It should be just log of x. I don't know why I wrote log 10. It should be log of x. It's log base 10 of x. So the log looks like the exponential after it's been reflected over this diagonal line. Oof.
Wow.
Already at the beginning. So unhelpful. Alright, so ignore those weird dashes. But so a log is going to be reflected over the line y equals x. So that's why it has that kind of weird shape. So a log is vertically inclined, whereas a exponential has that flat part and then rows. This one's going to have a vertical part and then bend off to either the right or the left. So they have the same kind of shape after you've reflected it over. So this is what your equation looks like for a log. Right, so it has a, h, and k, just like we're used to seeing. A is at the front, h is inside the parentheses with x, and k is at the very, very end, just like we're used to seeing. And they all say represent the same thing in this equation. A is a stretch, compress, or reflect. H is your left versus right, and K is your up versus down. So it's all the same stuff that we've seen before. There are going to be multiple parent functions. It depends on the base. So they're very rarely going to say, what's the parent function? Because there are different ones for each base. All right, what kind of asymptote did we have for the exponential? It was horizontal, right? We had a horizontal asymptote for the exponential. What kind do you think we have for this one? It's vertical. So the exponential graphs have the horizontal asymptote, and this one has the vertical asymptote. One way to remember that, think about the letter L in logarithm. L is straight up and down, right? So if you think about the L in log, that can remind you that the asymptote is supposed to be the vertical one.
The L in log.
Okay, what's the equation for the horizontal, the vertical asymptote? It's no.
X equals, you know what?
H. The K is for the horizontal. The horizontal for the exponential is y equals k. The vertical asymptote is x equals h. So where do you look at the equation to find the vertical asymptote? Inside the parentheses. For the exponential, you look at the very end. Remember I was circling it? That's what I used to do in high school. I would circle the k. That's for the exponential. For the log, since it's a vertical asymptote, you look inside for h. Okay? So when you guys are graphing, you're going to find the asymptote first, so you can have that boundary set. And then your guys' does look a little bit different than what I have printed up here. So your guys should say finding points using the calculator or the key points plus transformations. You guys see that on your notes, it's not printed up here. I want you guys to cancel out the part that says calculator. Cancel out that part where it says like use change of base in the calculator to find points. That is one way of doing it, but because calculators are difficult to type the fraction of logs in there, especially when you have extra stuff being added or multiplied onto it, it'd be really hard to enter into the calculator to grab it. So we're going to be doing something else. The way that I know it looks different on here. The part of the notes that you guys want to highlight is where it says key points plus transformations. That's the method we're going to be using to graph a log. right? And it's unique to a log. You can't use that for an exponential, so it's going to be a little bit different. The key points are 1, 0, and B, comma, A. Yeah, I know, it just doesn't say that there. I use the word loba to help me remember this. Because 1 looks like an L, so it spells out loba.
Oh.
L-O-B-A, loba. I made up that, it's not a made up word, but like I would pretend that they were all letters and I'd say it and that would help me remember what the key points are. No, you want to say it the way that they're organized because if you're doing the wrong order.
So it says I-O.
Whatever, you can make up whatever word you want, but I'm going to refer to it as loba.
Or just one
So you're-
comma 0.
Yeah.
Okay, so if you remember it that way, that's fine. I needed words. Okay, I needed mnemonics. Right. So this rule, and I'm going to refer to it as the loba rule. So that's why I'm telling you what I mean.
Oh.
So one of your points is going to be 1, 0. Right? The other one is going to be BA. The B and the A come from your equation. So the B is the base, and the A is the number at the front. So whatever those two numbers are, that will give you one of these points. But then you'll notice in your notes it also says transformations. So these are going to be your kind of foundation, but you need to move those points according to the transformations. So this is where they would be if you didn't transform your graph, but if you're going up to and right something, then you need to graph those points and then move them according to the transformations. So now you don't just graph these, you have to graph those and then move them with the transformations. Okay? So it's a two-step process. Find out what the key points are, and then move them with the transformation, and that's how you graph it. Okay, so you don't have to go into your calculator, you just need to know that rule for the key points and what the transformations are. Okay? We can find the same information as last time. We can find the intercepts, the domain, and range. You do not want to use the table or the calc 0. Remember when we did that trick I showed you in the calculator, the second trace and then left bound, right bound? That's not going to work for a log.
Wow.
Because of the shape of the log, of how narrow, steep, or inverse of steep it is at the x-intercept, or how far away it is. Usually they're like in the hundreds. The x-intercept is like 100 something. Sometimes, but not always. You can't always use the calc 0, right? So what we're going to do is we're going to solve. We learned that last time. We couldn't solve on day 1, so we didn't know how to solve yet. But now that we know how to solve, then you can find the x-intercept by solving. Isn't an x-intercept the same thing as a solution? Yes. So whenever you guys are finding x, if you guys didn't like the calc 0 or the second trace method, you can ignore it now. Now that we know how to solve, if you didn't like it for day 1, forget it. Don't do that. Just solve. Now that we know how to do that. Okay? So that's what we're going to practice here. We're going to use solving to find the x-intercept, and then instead of using the table again, we're going to plug 0 in for x to find the y-intercept. And I'll show you how to do that too. Very straightforward. You just type in numbers into your calculator. And then the end behavior is going to depend on the vertical asymptote, but in a very strange way. And you will see once we get to another example. Benjamin. Say with us, buddy. I know John's not here to yell at you, so I have to do his job. Keep your head up, please. No sleeping in my class, even if John's not here. Alright, so we're going to practice with this one right here. So we're going to find the asymptote, and then we're going to use the loba points to find how we're going to graph this. Alright, so the asymptote, let's find that first. You can tell me what the asymptote would be.
Vertical.
0. You're supposed to use h. H is inside the parentheses with your x. So the asymptote is x equals 0, because h is 0. So you're going to come over here on the axis, draw your vertical, draw your vertical asymptote.
Weird.
Huh?
Weird.
How's it weird?
Because I said.
You're not used to a vertical asymptote being at 0?
No, I'm not used to writing it that way. Vertical.
Okay. Alright, now we're going to do the loba points. Alright, so 1, 0, it's stuck. That's not going to change. Yet. Not yet. So now we're going to plug in B and A. What's the base for this one?
No.
10.
Base is 10.
A.
Small.
Remember when you don't see it, when it's a log, it's base 10, and then what's A? The number at the front, the coefficient 2. Okay, so what I want you guys to do is I want you to graph those points with x's. So those are going to be temporary. Those are not our final points, those are just temporary. So I'm going to draw little x's to represent those. So that's one of them, and then 10, 2, right there. So those are temporary. This is where our graph started if there were no transformations. This is the parent function for this particular graph. But now we need to figure out what transformations happen so we can move those points. We're not going to solve, just find the transformation. We already took care of the 2. The 2 was taken care of. So what does that do? Up 3. Remember, K is your up versus down.
That's it.
That's the only transformation. We took care of the 2 with the logo. We already took care of that. So the only other transformation is up 3. So to graph this, you're going to take your key points that you sketched, and you're going to move them both up 3 and graph them. So 1, 2, 3 is right here. And 1, 2, 3 is right here. Our transformation was up. So you go to your key points that we just sketched. Those were not the actual points, they were just sketches. And you move them both up 3, so that's a transformation. Logo. You can erase them if you want to, but
So like
that's where you just make them like little X's, little faint dots. You don't have to erase them. Okay, that's how you graph it. You find the loba points using B and A, and then you find the transformations and move them. And then you're done. Okay, we're not there yet. Is everybody good with the graph? Okay, finding the x-intercepts. Previously, we were able to just look at the graph or use the second trace 2 thing. It is not a whole number, right? See, the 2 exact points are here and here, so our x-intercept is not a whole number, so I can't see it on the picture. When you can't visually see it, you have to solve, okay? So in this space down here, I'm going to solve the equation, this one right here. You have to set it equal to 0. We're going to pretend this is a question that you guys just saw on the homework and the quiz. How would I solve this for x?
You gotta get rid of that 3.
Okay, so what would I do? I subtract it.
Yeah.
Negative 3 equals 2 log x. Alright.
Now you gotta get rid of that 2.
Okay, so you're going to divide. So that'd be negative 1.5 equals x. Alright.
Now you just
No.
no.
How do you solve? We just did housekeeping right now.
Oh, yeah.
The loop rule. The loop. You have to convert
10
10 to the
negative
so the negative 1.5 equals
F.
x. Once you have x by itself, that's the x-intercept. So you just write it as a point. 10 to the negative 1.5 comma 0. That's it. Well, it's not no solution, it's just a very small number. You don't have to simplify it, you don't have to give it to me as a decimal. Just once you solve for x, write exactly what you saw on the line and you're good. Alright, this process here, you can also use solving on day 1 stuff. So if you didn't like the second trace, whatever, in your calculator, and you want to find the x-intercept, you can also solve on the exponential.
can we use trace for that?
No, I was just saying that, it will not work. Alright, for the y-intercept, take a look. What do you guys think about the y-intercept?
Zero.
Is it going to intersect the y-axis?
No.
No.
Line.
No, it's not
No,
0,
it's
0.
not. No,
It's
it's
not.
not.
It does not exist.
I know.
It's not going to hit the axis. There's nothing down there. Alright? What about the domain?
It's a different story. Standard notation.
We are limited for the domain.
Is it greater than something?
Right here, what is it?
No, infinity.
X equals.
Or 3 to closer to wait, whatever it's like 1 to closer.
There you go. It's 1 to infinity. What's the furthest left we have? The asymptote, which is at, no, not 1, 0. Sorry.
What?
It's at 0. The asymptote is 0, right? So your domain is your furthest left boundary, which is 0, the asymptote. And then your right boundary is positive infinity, because you go further to the right. So it's 0 to infinity. How would I write that as set builder?
X
Equals.
Nope.
No. Let's. Okay.
Greater than what?
0.
Greater than 0.
Oh my god.
All of the x's on your graph are bigger than 0.
I'm trying.
Alright, what's the range?
It's a.
DNE.
All real numbers.
It's all real numbers.
Oh.
Isn't it going down forever? Isn't it also going up forever? Gradually, but yes. So this one's all real numbers.
So we write all real.
Do you guys remember what happened with the exponentials? What was the domain and range situation for the exponentials? The domain was all real numbers, and the range was the one that had the inequality. Because these are inverses, they get swapped. Inverse for an inverse, everything gets swapped. So for an exponential, it's the domain that's all real numbers. For a log, it's the range that's all real numbers. And then you just use your eyes to analyze the graph. You don't even need the graph, actually. You just know what the vertical asymptote is and whether you're going left or right. And you can write the domain. Alright, the end behavior is what's weird. The end behavior is what's strange. So, when when we're talking about the left side of a graph, how do we normally say left? We say that x arrow negative infinity is how we say left, right? Because when you guys are thinking left, you're like, okay, I'm going this way, and the furthest I can go on the left is negative infinity. Can my graph get to negative infinity? No. It can try, but it won't be able to.
It's too small.
So when I'm asking you guys to define left for me, what's the definition of left in this graph?
It's to that one right there.
Which is
Just
zero.
to the zero.
So left is now 0 instead of negative infinity. Negative infinity used to be the furthest we could go, but for this graph, the furthest we can go is 0. So 0 is now our definition of the left. Okay, I know it's a little bit weird.
So, let me just write this real quick.
So it's 0.
So the asymptote will always be
The asymptote will be the furthest left you can go. It could be on the right side if this was flipped. If it was the other way around, so it was pointing that way, then the asymptote would be pointing to the right. So whatever side the asymptote's on.
So will the x always be 0?
No, it depends on what the asymptote is. If the asymptote was like -2 or something, then it would be -2.
Alright.
Alright, so as your graph is going towards 0, so that's the furthest left it can go, so as your x's are getting closer to 0, what's your y doing?
Getting better.
It's going to negative infinity. The rest of it's normal. It's just that one that's weird. So as your x's are getting closer, or they're approaching 0, your graph is going down towards negative infinity. As your x's are going this way, what's the furthest right they can go? That one's infinity, so that one's normal. And as you're going to the right, what's your graph doing? It's going up. So the rest of the end behavior is normal, just like you're used to seeing. It's just the left side, whatever side is interrupted by the asymptote.
Is that how it will always be?
For a lot.
It's going to be asymptote for the first x.
No, I was just describing for Robert. If it was the other way around, so if this was on this side pointing that way, then the asymptote would be defining the right, not the left. So to figure out what side of the graph the asymptote is. Alright, any questions about that first example? Questions on the first example? Alright, second example here. First thing you guys want to do is find the asymptote and the logo points. What's the asymptote? Nobody's saying the full correct answer.
X is
Asymptote is -4.
X equals -4. Remember, H is the opposite of what you see. So you pull it out, change the sign. Okay? So that's graph -4 is right here. Okay? Then what are the points? What are my initial points that I'm going to be using?
Well, you have 1, 0, and then you have the base, and the little base.
What he said.
Okay, so LOBA, you have 1, 0, and then BA. So what's the base? 3. And what's A?
0.
0.
Nothing's there. Oh, -1.
-1. If nothing's there, it's not 0, it's 1. Alright, so now we're going to graph those really lightly with little x's. So we have 1, 0, and 3, -1. Temporary, so that's not where they're actually going to be. And now we need to find the transformation so we can move those. So look back at the function here. We already took care of the -1 as a transformation. Are there any others? No. No, we already took care of that.
Left.
What does this do?
To the left.
It's left. So we do that one. Left 4. Your up versus down is K, which would be on the outside. We don't have any K values. Alright, so once you guys list the transformations, you're going to go back here to the points that we have temporarily sitting there. And you're going to move them both to the left 4. 1, 2, 3, 4.
A lot of work.
How do you know which way the arrow
1,
is?
2, 3, 4 seconds.
Like, how do you know if it's like the arrows?
Give me a second. My board is acting up.
There's nothing I can also
I'm not gonna say it.
What? Yeah,
Like whether it's facing like up or down.
yeah.
It's based on the transformations really. So what does the negative at the front tell you about the graph?
It's going down.
No, yes. So if it's negative, that means that it's falling. It's been reflected. So that's how you can tell that it's going to be going down instead of up. So this graph is going to be going like this. So if you see a negative, that means it was reflected over the x-axis. So instead of going up and over, it's going to be going
Down and up.
Wait, so where should we move the points over?
So I had, these were the logo points, the 1, 0, and the 3, -1. You said the transformation was left 4, so I took each of them and shifted them
Oh,
left
so
4.
the other way.
And I just connected us. Okay? Alright, x-intercept.
I would always go into the right.
But what about
Like-
Yes, so you'll always be on the right side of the graph because they shouldn't give you a y-axis reflection. A y-axis would be then going this way. And I seriously doubt they're going to give you one. So most often they're going to be on this side of the graph. They'd be very, very mean to give you the one. Alright, x-intercept. Is it a whole number that you can see on the graph?
Apparently,
Is there an exact point on the x-axis? What is it?
negative
I believe it's -3.
-3.
0.
What?
-3, 0. So if it's on the graph, you don't have to solve for it. You can just see it and write it.
Yeah.
Okay.
Nah.
What's wrong? Okay. Alright, the y-intercept. We do have a y-intercept for this one, but it's some sort of fraction because it's not an exact point. So how do you think we're going to find the y-intercept?
Calculation.
Don't. I already said it's really difficult to plug it into the calculator, so we can't use the table of values. What's the generic way that you find the y-intercept?
Plug it in.
0.
Plug it in.
What about 0?
Comma.
Plug 0 in for x.
Yeah, that's what I meant.
So what you guys want to do
Plug.
is find the value of
Negative
this.
1.
Because when you plug 0 in, 0 plus 4 is just 4. So you guys want to find this. You know how to do that. We did it on day 2. If you didn't have the negative, how would you just find log base 3 or 4? You do that division thing, right? You do log of 4 divided by log of 3, and then whatever that is, just make it negative.
So you get negative 1.26.
Let's round.
No,
Then you get
negative
1.3,
1.3.
Yes.
and then you have to come up.
And my bank account.
So the generic way of finding the y-intercept is just plugging 0 in for x. We've done that for almost everything else except for the exponentials because we already had our calculator set. But because it's more difficult to use the calculator, just use the generic method that we have been using before. Plug 0 in for x and then just evaluate. Okay? What's the domain?
It's freaking all over. So
Where does your domain start? -4. And where does it end?
Infinity.
Infinity. So there's your interval notation. How would I write that in step builder?
X.
greater.
It's not all real numbers. It's greater than
Negative 4.
-4. What's your range?
No.
Your range is all real numbers. So negative infinity to positive infinity. And then y is equal to fancy r. Yeah.
So you write an R and you draw a line.
I draw 2 lines and then an r over it.
I draw a big one.
I draw an R and then us.
I draw
Okay,
an
okay,
R.
fine. You guys can draw however you want. Alright. I'm going to do the left end behavior first. What's the furthest left that my graph can go?
-4.
-4. So as my x's are going towards -4, what's the y doing? Going up. So the second half of the end behavior, y is going toward infinity. And then as my x's are going to the right, what's the farthest they can go? Infinity. What's my graph doing on that side?
Negative infinity.
It's falling.
Wait, it is?
Yeah.
It's very gradual, but it is dipping down. See how this point is lower than that one?
Oh.
You're decreasing.
ALG2.
Okay? So it's just another one.
I'm sorry.
You guys think you can do the next one on your own? Why don't you try doing the parts of it that you think you can do, and then we'll come back together and fill in the gaps. Alright, so try the parts that you think you can do, and then we'll come back together and do the whole thing.
Wait, is the asymptote inside?
Just try it yourself, and then we'll come back
I
together.
feel like the last one is always the hardest one. Like, you always
Yeah, you always leave us the hard one. And you're like, try it on your own. It's good.
She won.
No.
You guys?
Never that.
I knew it.
That's for.
Oh, sure. I wrote down everything. I got 9 pounds.
One thing.
I have 99 pounds here, so that's me out.
What's going on?
Okay, that's.
Wait, how do you draw it down?
No,
You didn't even draw it.
Just think about it, Liz.
When you graph that,
straight line goes.
when you graph that jump from here, see.
Oh, no.
Yeah.
Damn.
One more than graph that I have from the beginning.
But you said x equals 1. This is not.
Transformations are good.
They are good.
They are good. Okay, well, what about for the points?
So we need to do the logo points.
So it's like this thing.
Base, that's the beat.
Oh, 4.
Or, I don't know what's X.
What's the ultra? 1.
So you're gonna graph the asymptote, so that's scale 1. That's 0, 1. Oh, just kidding. Can't pass it on.
Raise your hand.
I'll write it down as 1.
I was watching Ninja and Drake play on Is that what I said?
And then you draw little X's at those points.
Liz, I need your help.
And then you move them according to your
Yeah. They played again yesterday. I was on my stream. And it was like a random game.
No, it's not so confusing right now.
Never mind. Do you ever just feel like crying? Because I feel like crying right now.
You guys want to talk about it?
So when you know life has pushed you way too far.
Nah, man, so let's go for
That's fine.
Nah, let's go for
You said this
I'm the same one.
Okay, we're
not
just.
ready to I'm being
Alright, who can tell me how they started it? Who can start the process off for us?
Alright, so you have
Right one, down one.
Oh, you have to draw the arrow to the asymptote. Yeah.
X equals 1. X equals 1. So then you got to
Everybody get that? Hold on.
Yeah.
The asymptote is 1 and the transformations are right 1, down 1. Yes?
Yeah.
Wait,
I
down
know.
what?
Right 1, down.
Oh,
Down 1.
Let it L.
what's that L?
I was gonna say something, but don't. Okay, so. What's the next thing I would do? What's the next thing I would do?
So you gotta write down the 1, 0 beat A joint.
Oh, you have to draw it first.
That's what we're trying to do.
You have to
Yeah, you
draw.
think this. So
Draw.
Okay, now what?
now you do U plus 20.
You keep solving.
Plug in the base and the A. So what's the base?
4.
4. What's the A?
0.
No.
1.
How did I manage to goof this much?
You cannot multiply times 0 as a coefficient, guys. That would mean the entire thing would be blank.
What's on the book?
Because multiple people said 0, alright? You can't multiply times 0 as a...
I did
I
it.
heard several people say 0.
I don't know.
When it's an unknown coefficient, it's a 1. Or when it's invisible. Okay, so these are the initial points. It's going to seem a little bit weird that it starts on the asymptote, but it's not going to stay there, so it's okay. This is our initial point. So 1, 0, and 4, 1. Those are the logo points. They're not going to
That's
stay
why I
there.
was goofy.
Now, you have to take those points, and you're going to go right 1, down 1. And then... Alright, so your logo points were initially in one position, and then you use the transformations to move them right 1, down 1. Alright, do we have an exact x-intercept on the graph?
No.
Yeah.
Yes, we do.
We have 5, 0.
5, 0. So this one you didn't have to solve, but again, if it wasn't exact, you didn't have an exact point there, you would just set this equal to 0 and solve like we did on day 2. Do we have an exact y-intercept?
No.
No. Will we ever have a y-intercept?
No.
No, because it can't get there because the asymptote's in play.
So there's
None.
nothing.
Alright, domain?
Next one.
X is greater than
No, 1, comma. Infinity.
Okay.
Close.
X
Greater.
greater than 1.
Okay. Range?
Negative.
All real numbers.
All real numbers.
Yeah.
Double R.
Why?
Two lines on the.
Scott.
Alright, who wants to try the end behavior?
It's X, 1. Oh, I was right.
Y.
That's your left side. The left side of your graph is represented
And
with
then it
1.
goes on negative infinity.
Goes down.
And then you come back up to positive. It's positive.
Right. Okay?
Real
So
quick.
that's how you graph and analyze.
Really quick.
The absolute is H.
It's H. For the vertical. Alright, here are those questions that we've looked at for the exponential. Your SOL type questions. So these, remember for SOL, they could give you a picture and some equations to choose from, or an equation and a bunch of pictures to choose from.
Yeah.
This is the type where they give you a picture and they want you to pick the equation. So, remember there are 3 things we looked at for the exponential, whether it was a growth or a decay, what the asymptote was, and then checking the points.
Where's that?
Well, it's not going to be graphed for you. Right? They're not going to graph either horizontal or vertical asymptotes. So the 2 things you guys have to check is the vertical asymptote, why is it saying right? And the points. Right, because this is a log, right, you can see all of your answer choices are logarithms. The tricky thing that they're going to do to you on the test and the SOL, listen. The tricky thing they're going to do to you on the test for this unit and the SOL is they're not going to give you just logs or just exponentials. They're going to mix them together. So you guys need to know the difference in the appearance of the graphs. A log is vertical and then goes off to the side, whereas an exponential is flat and then goes up, where it comes down and flattens out. So you guys need to know the difference between the shapes of the graphs. Okay, so we'll mix it up. Alright, but for this one I want to be exclusively logs. So you need to check to see which one has the appropriate vertical asymptote. So just looking at the graph, what's the apparent asymptote?
That one.
It's at 2, right? They're not going to draw it, but you can draw it in for yourself. So it looks like the asymptote's 2. Do any of these not have
D.
the vertical asymptote of 2?
No.
They all have
True.
the correct asymptote plugged into the equation. So we can't narrow down our options based on the vertical asymptote. So what we're going to do now is compare the loba points. Right? See how I have some exact points on this graph? We're going to find the points for each of these graphs and see which ones will work. Okay? They are all the same. Well, the first two are the same base as well as the third one, and this one's base 3. So we're just going to go through this process. Takes a little bit more time than the other one. You have to find the points for each of the graphs and find the one that matches. So we're going to do the first one. What would the initial points be? 1, 0, and what for this? 2, 2, 1. Okay. And then what would the transformations be for the first one? Because it's base and okay. So go right 2 and down 4. So let's move our loba points and see if they end up where they are on the graph. So if I started at 1, 0, and then I go right 2 down 4. 1, 2, 1, 2, 3, 4. Is that one of the points on the graph? No, that's not it. That's not it.
Why did you go right 2 down 4?
Because that's where the transformations are, Elizabeth. Here's the transformation points. Alright, what about this one? What are the loba points for this? 1, 0, and 2, 1. It's the same loba points, but we're going to have different transformations. What are the transformations for this one? Right 2 down 5.
We got
So let's do 1, 0. You go over 2 and down 5. Is that one of the points?
Yeah.
Yeah? Does it work for the other one? 2, 1?
Let's
1,
see.
2, 1, 2, 3, 4, 5. You also get a point on the graph? Yep. So that's the one you want.
Hey.
Don't we continue on to make sure the other...
No, because the loba only gives you 2 points, so you just need to check both of them. Right? You can't just depend it on the first point. You have to check both. Okay, always check both. Alright, is that good? I need to do the next one? You guys okay with that? Okay.
Yeah, let's do it.
Yeah, okay. Let's do it really fast. So, what's the asymptote? 0. 0. You can draw it if you want to. Okay, are there any that don't have an asymptote of 0?
Yes.
Which ones?
The last 3.
The second one.
Oh wait,
The
no,
last
The second
the
one?
second one, the last.
And the last one.
And that.
Okay? These both have asymptotes of 6. Okay? So now we need to figure out which one of those 2 is the correct one. So let's find the loba points for this one. It would be 1, 0, and what?
1 more.
This one, what's the second loba point? 10, 10, and 1. Because B, the base is 10, because it's not written there, and the A is a 1. So then, what are the transformations? Down 5. So, 1, 0, 1, 2, 3, 4, 5. Is that one of the points on the graph? No, so that's not it. It's going to be your third one.
Gosh.
Okay?
We did it.
Alright, I'm not going to do the exponents of y except for the end behavior because we practiced that on the previous page. So everybody good with that?
We done?
No, we're going to talk about inverses. Or briefly. Alright? Inverses is stuff we've done already. I just want to introduce it to you in the context of log and exponential, even though we've done it already. So if I give you an equation and ask you to solve for the inverse, what do you do? What's the process?
Just switch lines.
Okay?
What the hell?
I don't know. Switch x and y, and then what?
Solve for x.
No.
Solve for y.
Solve for y. Yep. This is what we've been doing ever since we learned inverses, and we've had one on every other graded assignment, if not all. So when you guys are trying to find the inverse, you switch the x and y in the equation, and then you just solve for y. Okay? So we're just going to do that. We have this side, which is the exponential, and the other side, which is the log. Gavin. Alright, so what would I do for this first one?
So x equals 2y.
Okay? X equals 2 to the y minus 3. See that? Now I need to solve that for y.
So you ask me also.
Add 3. This is just like we did on day 2 with the solving. Housekeeping comes first.
Divide.
Nope. You can't divide that as an
Or
exponent.
square of 1.
No. Guys, how do you solve when it's an
You
exponential?
subtract
Or
3.
multiply those sides by 1.
Come on now,
You
guys.
square root it.
All around.
Literally just did this. Last lesson on the homework on the quiz that we just did today.
The log thing.
Thank you. You convert to the uniform. You
Yeah.
cannot divide by 2 because it has an exponent. You cannot take the square root. Okay? Good grief. Alright. Yeah, somebody, I know somebody's gonna do that, but I'm just telling you, don't do that. When it's an exponential equation where the variable's in the exponent, you have to convert it to a log.
Log.
So it's log
The log.
what?
Log 2.
Where's the one?
Log 2.
Right there.
Log 2.
Oh, okay.
Log base 2
Subscript.
of
Of x plus 3
equals.
y 2.
Okay. Once you have y by itself,
Oh,
you're done.
right. Oh, I didn't know.
That's the answer?
That's it.
Copy.
You're just trying to solve for y.
Say Lizzle, my nigga.
Schnitzel.
Alright, once you get y by itself, you're done. That's the inverse.
Okay.
Okay?
On to the next one.
What about this next one? Do I divide by 3? No.
I didn't even do
Okay.
anything.
What do I start with?
Where's the answer to for this?
Combine like
The
terms.
notes.
Oh,
Combine like terms? What? What do you guys do first?
So it will be
Inverse. What do you do first?
You gotta log.
Oh, you have to change the X to a Y. There you go.
there is no answer.
Okay, we switch x and y. That's always what you do first for an inverse. Is there any housekeeping I have to take care of?
No.
No. So what do I do first? For
Log.
next.
Log.
Convert it to a log.
Log.
Log
Base 3.
base 3
Parentheses,
x
X plus 4.
Wait, do we need
No.
do we need parentheses?
y
Or-
plus
Yes.
4.
Oh,
Equals
Y plus 4.
y plus 4. See, I'll show you why you need parentheses in just a second.
Take your time.
Alright, is the y by itself?
No,
No.
just
Not
subtract.
currently, so now you're just going to subtract the 4 over. So log base 3 of x minus 4. Now the reason why the parentheses are important is because it tells you the difference between whether the negative 4 is inside the log or outside.
And it is not.
It is not inside the log, so that's why we want to close the parentheses so we know the difference. Okay, there's a difference between having just x as the input for the log and having x minus 4 as the input for the log. So be really careful you're able to distinguish. They won't do that all the time. Okay? They won't, like, for example, up here, see this example? There
Yeah.
are no parentheses.
Do they want us to do?
No.
They
I'm
do.
just saying, if they don't include parentheses, do they
Yes.
intend for the negative 3 to be inside or not?
No.
No. If they don't include parentheses, they're expecting you to understand that the negative 3 is on the outside.
You know what? I'm gonna put my own part.
You can put your own parentheses if you would like. Alright, let's switch over to this one then. Let's switch over to this. No, switch over to this. Alright, what would I have to do first?
Switch it.
Okay. So x equals
Log.
log.
Base 2 parentheses Y minus 3.
Okay. To put some parentheses of your own to clarify how that's gonna work. Then what?
You gotta move over the. You just flip and send it.
Simplify.
You have
Oh, you gotta add
can't
3.
convert yet. You have to move the 3 over. X plus 3. Log base 2.
We didn't have to 40.
Well, no.
You want to do like
Right.
matrix or something.
Now they're taking care of the housekeeping. What do I do now?
We help with the keeping.
You gotta do the square root.
We help them
2
clean.
2.
raised to the X plus 3 equals.
Yep. And once y is by itself, you're done. So that's it.
We calculate.
Alright? Try the next one on your own, please.
Wow.
Oh, yeah.
We know that John hard. That's
Let's do it.
It's hard.
She said,
That's what we
but I
do.
thought
with the
you
John.
did.
It's the hard one.
We're on strike.
Let's do it. You can do it. I know you can. Alright. Come on.
This is good on Instagram.
Don't be a jerk.
This is John on Instagram.
Damn. That is
Damn.
quite the insult.
Whoa, I can't see so well with all this shit.
No, I don't.
No, for real.
I did ducking cookies and shots underground.
Walk right out of class. It'll be like, hey, green, and I'm like, yo, what the
No,
fuck?
this is inside, so you don't spread. Oh my god. That's the difference between this is inside.
You know what I'm saying?
Yeah, you told me like 3 times already.
I understand this.
Yeah,
Yeah, what'd you do, man? Gavin, what'd you do?
wait. No, so you go this way. Why did I get back
Yo,
to that?
okay, you're not funny. That's my mistake.
Alright, I can say that down on this.
Yep, so now you just get wild.
Oh, yeah. Yo, did you?
I'm trying to
See, we even have to number these questions. How much do you want us to do?
I got a question for
Miss Ken, can you show us?
Well, can somebody explain to me how they do it?
Which one? Oh, do the swirl. Oh.
Not yet. Just yeah, exactly what Carlos.
So you-
Not yet.
You
We're
gotta,
gonna
you gotta
start.
split variables. You gotta split the variables about the same equation.
You should at least get this far. But
Yeah, not easy.
Oh, wait, why don't
Down
you not
to
just
the
practice the one for
Now you're on your own.
I think that's
well, they have your parentheses already set. So now they're defining for you that the 6 is inside the log now.
So you can't just subtract.
Yeah, you can't subtract the 6.
Yeah.
That's why it's so important you guys know the difference between when it's inside and when it's outside. This is inside the log, so you're not supposed to move the 6 over.
so the
So this is,
You
I
gotta
don't have any housekeeping to do, so just go.
You gotta do a roundabout.
I did it the wrong way.
You gotta do that.
You start at the base and you go towards the number on the other side of the equation.
So, yeah.
What's the base?
10x
Yeah.
and an x on the
And
top
keep my state.
equals y plus 6. And then you get. And
Okay,
then
so everybody see, get here.
What do you do when you get that?
you get
Subtract 60.
You see how I drew the loop? Just like we practiced.
No, I know, but like where do you put the 6 if you subtract it? Because it's not supposed to be a lot.
It's flat with the 10. So you have 10 to the x, and then minus 6 is just flat with the 10. So the x is the only thing in the exponential, yeah, the exponential position. Everything else is on the same level, I guess is how you're writing it. Right?
Wait, so that's the answer, right?
Yes. Once you get y by itself, you're done. Alright, now what I want you guys to do is pick one of the 2 bottom ones, either this one or that one, and do it.
I call the left.
I'll put both of the answers up in a second, but I want you to pick one of those 2 and do it all the way through. And then I'll put the answers up so you guys can check.
Damn.
Pick one and do it.
I guess.
I guess unemployed myself.
Cheer in the conference.
oh my god, stop. Can you show me?
You can't convert, you did not.
What do you need? You need a last
I think that's the answer.
Hurry up.
Yeah, I did.
If you like it, then you should, but.
LN? You get the LN. Oh, lock.
Hey, can you show us how you got the answers? Dang. It's on the
Power of
wall.
Milwaukee.
Por favor.
Let's go!
What's that wrong?
I got it right.
Oh,
I mean, did we do it for this one?
Oh, God,
No.
move the board.
Wait, it's touch?
Gamble that jump. She said.
I'm sorry.
I'm sorry.
I don't even know how to move it back.
Do Control Z.
Yo, swipe
No, it doesn't work all the time.
Adios.
What can I say? Everything I touch just goes to garbage. There we go. That works.
Let's go. I know how to do it now.
Right, I know. I think because you're not like this.
Sorry.
It's just like, the next one, when they come back.
Oh,
Language.
so it's like.
I know what really should be.
I'm just saying.
I got this.
Whatever happens
I'm
in
just
good
saying, you shouldn't be saying what you're just saying.
This guy.
Whatever happens to some good old fashioned cooking.
How did you get the left one?
Good old fashioned propane.
Same process as we did before?
What?
Yeah, there you go.
You smart.
Alright, so whichever one you guys chose, write down the answer. I'm not gonna explain it, you guys have to work it out.
Yo, I still would
Hey, I already worked out on the right side.
I came in confident.
You can work it out amongst yourselves and teach each other, but I'm not gonna spend time discussing that.
Came in confident.
I charge you $50 an hour.
I wanna finish with this last one. So I don't want you guys to be confused when you see something like this on the test. So when you guys are reading the directions, you're going to see graph the inverse of blank, right? This is super important. You guys notice that it says inverse of.
So we're going for Y.
So if you accidentally graph this, would that be the answer?
No.
No, because they want the inverse of that. So there's two ways to do this, right? So one way would be to graph this and then invert the points. Remember, so if I said like a point was 2, 1, what's the inverse point? 1, 2. So you can graph this. If you like this, like this is maybe easier for you to graph, you can graph that, and then whatever the points are, you can invert them, and then that would be your final answer when you graph it. So graph the original, and then invert points. You have to graph the original one really lightly, and then erase it, and then regraph the inverted points. That's one way to do it. The other way would be to solve for the inverse and then graph that. Just like we were doing up here. If they ask you to graph the inverse of this, you can solve for the inverse like we were just doing and then graph that. So let's say you guys prefer graphing exponentials as opposed to logs. If they give you a log and say graph the inverse or whatever, you guys can solve for the exponential because that's easier for you to graph, and then you can graph that one. So if you don't like this and you would not prefer to graph that, you can always convert it to the other one, to the inverse form, and graph that. So there are two different ways, so just be aware of those two different methods when you see it in the future. Alright? So that's finding inverses and graphing and analyzing logs. Does anybody have any questions? We will take a 2-minute break for you guys to relax, and then we're going to continue working on the graded assignment. So I want to make sure that you guys have enough time to get it done. Okay? Take a quick break that does not involve phones. Just relax for a second, and then we're going to work on the graded assignment or homework, whichever is your priority right now, until the end of class.
Yeah, great assignment.
The graded assignment is due on Tuesday, so you're only gonna. This Tuesday has passed, so Tuesday is currently passing right now. It is currently Tuesday right now. It is passing. Okay, next Thursday. Or sorry, next Tuesday. So the only other class you guys have to work on it besides today is Thursday. So I want you guys to get a lot of work done today so you can finish it on Thursday so I can collect it for Tuesday. Today my 2D is coming in, so I'm going to be working with her. And then I haven't marked it on here, but I do have a meeting until 3:45. My meeting shouldn't end somewhere between 3:30 and 3:45.
You're getting a raise? Oh, she drew that.
There. So the open box means that I'll be back somewhere between 3:45 and 4.
3:45.
Because you're not paying attention to sleep. Oh, into 0? Yeah. When did they say